Hi, everybody.
Howdy.
There we go. I'm Eric. I'm going to be your presenter for the next half an hour. Oh, boy. So this is where I work. If you want to email me, now you can do it. 1, 2, 3. Okay. This is my background. I did a bunch of stuff. I got to work for the White House. That's why I have a T-shirt that says White House on it, because I bought it at the White House. Whoa. All right. I don't really care about my background too much, especially for an audience like this, so I'm just going to jump right into the things. So the general gist of this talk, or the sort of theme here, is to teach you how to take the skills that you've acquired as data scientists and software engineers and then apply that to the social justice context. And I'm going to be doing that through a high-level algorithm of basically what I did. These are the condensed steps that I took to move my career from a place where I was only looking to make money to a place where I was looking to help people. Now, I have a slight advantage over all of you. I started thinking about this stuff when I was 12. So when I was 12, I was on vacation with my parents in India, and I saw slavery. And I saw a guy that actually looks a lot like this. And the image of a person that was enslaved really broke me, and I was like, all right, I'm going to help people for the rest of my life. And so I've just kind of been working towards that ever since. Technology and me being a math nerd and all that other stuff kind of helped. And so the key point here is that it has to start with a feeling. You have to want it. You have to want it more than anything else, because the pay in a lot of these social justice jobs are really low, like embarrassingly low. They've been getting better, and I've been pushing people in New York to pay software engineers more money, and that technology does actually matter. And in some cases, this has actually yielded real results. For instance, I used to work for the Manhattan DA's office, and they recently put up a posting for a software engineer for the entire department, and they're actually going to pay them like below market rate, but not like so much low that they can't afford to live or eat, which is basically the choice that I made when I worked there. So I moved back in with my parents, which was super fun, and then I got to save lives every day. All right. So once you have decided that you are going to do something semi-masochistic, and I'm going to argue that it's becoming less and less masochistic every single year, and that more and more people are waking up to the fact in the social justice space that you need software engineers if you really want to make an impact that scales, and data scientists, it's easier and easier to find your people. For me, this was the anti-trafficking folks that I worked with, and I went from basically being an academic that no one really listened to and constantly pushing my my advisors to be like, let me do anti-trafficking things, to being able to work with people on the ground that were like, yeah, let's try things, let's get out there, let's do it, and let's see what we can see. Let's find the results, and it fundamentally changed the direction of my career. And was, sorry, I'm just gonna get rid of this little iTunes jump-in window. That's what I get for trying to charge my phone while I give a talk. Please go away. All right. And so, yeah, being able to find the right set of folks with the domain expertise really was what was able to bring me to that next space. So the first thing I'm going to show you is a tool that I made. All right. So key points 1 and 2, just to summarize super fast. Make sure you want to do it, and then once you do it, find people to work with. And this is going to be a counterexample, because I did not find people to work with when I built this. So back in 2000 and I want to say, oh gosh, 11 or something, I made this tool. So what this does, and I actually should have had this slide up. I had it before, and then I decided to take it down. So anyway, so what this does is I wrote an analysis for the Huffington Post. I showed this pattern. In case you can't see that, so it was 2013, excuse me, on 2 days after Thanksgiving, so last week basically, but in 2013, there was a huge spike in the number of people that were on Craigslist looking for prostitution. Now, the reason why I bring this up is because some set of prostitution is human trafficking, specifically sex trafficking. This is not a talk about anti-trafficking work. This is a talk about how you can change the world, though, so I'm sort of jumping through a lot of the details. I have many other talks that are on the internet about anti-human trafficking, as well as there are now many other professionals that are doing this as well, so I encourage you to go check those out. Okay, so anyway, so I found this pattern. I thought that would be it. The way I found it is so now we're going to jump into the data science side of this. I wrote a text classifier. Hooray, like the first thing you do when you get out of grad school. I think this is approximately the right thing to do if you're going to do text classification. TF-IDF is not always the right call. I'm going to claim that that was a feature engineering thing that I did because I was dealing with advertisements, so it's paragraphs of text, and then people sort of soliciting the world either for text or the other way, right? They're either saying, I want to buy this, or I have this and want to give it to you. And so I was able to parse out pretty easily which were prostitution and which one weren't. And then from there, it was sort of anyone's guess. But you can sort of say from the magnitudinal shift on the day after Thanksgiving, or weekend after Thanksgiving, that there is something substantive here. Okay, so let's dive into the details of how this works. I set up a nice little pipeline. If you're not familiar with scikit-learn pipelining, basically what this does is sort of imagine that there are variables here. So there'd be a variable over here, there'd be a variable over here, and there'd be a variable over here. And you're sort of passing the data implicitly down the chain. So the variable comes in here, it's processed by this, and then there's a function call that happens for TF-IDF. So count vectorize happens first, then TF-IDF happens, and then the SGD classifier, which among other things does support vector classification, so SVC within the scikit-learn stack. When I ended up training this, it turned out that SVC was the most important thing, most important classifier, which I found kind of interesting. And I do a bunch of things. I'm regularizing, which is something you should also do. I'm using some parameter tuning. I'm setting a random state to ensure consistency, all these things. Notice that I have a call here for my lemmatizer, which I'm sort of wrapping in a standard way. If you're not familiar with lemmatization, it's super cool. It allows you to sort of say that things that are plurals, days becomes day semantically, which is what you care about when you're trying to classify text. You don't care about the difference between day or days. You're trying to get at some level of high-level semanticness to be able to put things into a bin, and so lemmatization is the right thing to do, I claim, and others claim. So I trust that. And I'm using the WordNet lemmatizer because I think it's pretty good. Okay, so this is not the cleanest version of this. There are other people in the Python community that will yell at me for using a class and then having a call, which basically means why the heck wasn't this just a function? And I'm going to claim there is some good reason for doing this because I'm setting up this lemmatizer, so there's this object that's instantiated inside of it, and it's a little weird to have a function where you have a lemmatizer, another class instantiated, and you're going to re-instantiate that class every time. So this allows me to store state. So this is one of the few places when I think it's actually defensible to do the thing that I did. Okay, so hopefully, if you want to argue about it, we can argue about it later. I'm certainly, game for that argument, but I think there's some defense here. Then the last thing I do is I just call this grid search thing. So hopefully this is a familiar thing for most of us in the scikit-learn space. All right. So you would think that this tool was great, I found this pattern. Cops are going to go arrest a bunch of people, whatever. There's culture change. Everyone realizes that trafficking is happening in New York City, and then they decide to do something about it. Maybe a little bit of that happened, but not to the same level that I was expecting. So essentially what I did is I built something crappy that was mostly wrong, and then I took it on the road. I gave a bunch of conference talks. So this was before I worked at the DA's office. I want to claim that, and that's important. But this talk, this analysis, allowed me to get my job at the DA's office. I gave this talk at Pi Gotham, I don't know, I guess it must have been in 2014. And there was someone in the audience from the DA's office who's like, we're starting up a human trafficking unit. Would you be interested in working on that? And I was like, absolutely, quit my job. And then, moved on to the DA's office. And that was made possible because I showed effort and interest, not because I built something that worked. When I actually started getting on the ground and working with people in the DA's office, I found, oh, this is basically useless. They know the problem is real. They need very specific help on specific things. And we'll get to some of the specifics that I was able to build for them, and hopefully gives you some ideas of what a good solution looks like technically. All right, so the next thing I built, I'm moderately, sorry. Okay, so I'm moderately proud of this thing, not because it's well designed. I cannot take credit for this. There was someone who helped me with at a hackathon, built the design. Because it actually shows something that is of value to people. Whoops, what is going on? Oh no. Okay, sorry, I clicked on the wrong tab. That one is still I actively work on this tool, so every once in a while things break, but that is not this is the link I wanted to show you. So all of these dots are places that I claim trafficking has happened in New York City. This is data that's very old, it's very stale. It's likely that these actual addresses no longer have sex trafficking happening at them. But this gives you a much better, more substantive view. And just to zoom in a little bit, these are places that we are kind of close to right now, right? So, okay, maybe I can't zoom in. Come on. Let's go, internet. Yeah, so these are places that we're kind of close to right now. This is not happening far away in some distant corner of New York City. This is happening in major locations. So you would think this then would raise the call and people would get more interested. Too bad, they already care. So all we're doing is saying, get angry about a thing that you're already angry about if you are already in this space. And if you're not already in this space, then it tells you. So all of us are very frustrated by this. But the people that work on this day out and day out are like, yeah, we know, great, you made us a prettier map. They don't actually care. So I would claim that being able to do that sort of thing, which is largely what the anti-trafficking space has been about for many years. I mean, making the call to arms is important. I can't underscore that enough. But the way that you really help people is honestly by doing things that are a little less sexy a lot of the time, but can still be, super useful. All right, so before I jump into the big, this is the thing that actually worked, we're going to go through the technical details of Investigator and how I sort of built that tool. And we're going to start by looking at VGG16. So VGG16 is a convolutional neural network. So I'm not doing anything crazy right now with this convnet. All I'm doing is importing the model from Keras because Keras is super awesome and comes wrapped with a whole bunch of architectures. If you're not familiar with Keras, congratulations. You just found the secret weapon to all of your neural network problems. You'll never have to try very hard again. The TensorFlow under API changes with some level of regularity that can, sorry, why is this not letting me, okay, come on. I can't, oh, I'm already at the bottom. I must have passed by it. Yeah, okay, this file's much shorter than I realized. Anyway, so VGG16 is one of these neural network architectures that comes out of the box, and it's really kind of amazing. And so what this is currently being used for is taking a bunch of pictures, and this is generally what it's used for. It's taking a bunch of pictures and then doing image detection, especially when you use ImageNet. Now, granted, you can use this architecture for a whole bunch of other things like image classification, facial recognition. It's all about the training data that you pass it, right? So here we're passing in the ImageNet weights, and that is what allows this to be used as an object detection neural network, so to speak. So the data is kind of informing the use case. All right, so how is this actually happening? We just read in the model, right? So the image here, let me see where we're getting that from. So image is also a pre-processing step that comes from Keras, completely free and just kind of available for us. So we're just loading that in. And then the reason we set the target size is because I cut all the images down to 224 by 224. So that's just something that comes that I'm setting. I should not have hard coded that, but whatever. It made the object detection reasonably easy to do at that size for some reason. I don't fully understand how image sizing affects object detection. I think it has to do with pixels, but there's probably something more nuanced here in any event. So I set the pixel size to that by that. And then, there's all these nice utilities that you get. So image to array turns it into an NumPy array. So then you can do your standard neural network stuff that you might want to do at any given point. Expand dims flattens things. I'm choosing the 0th axis because it's flattening across the rows, not the columns. And then I have this preprocessor that I wrote. I think I did not. Okay, this is also a VGG16 thing. Magic! So we're getting a lot for free because Keras is kind of amazing and sort of expects you to be doing object detection with it. So if I haven't convinced you that Keras is the greatest thing ever, then I don't know what else will. If you're not doing cutting-edge neural network research, if you're doing cutting-net research and you want to do the capsule net or whatever that Hinton just invented a couple weeks ago or a month ago at this point, then this is not the right thing for you. If you're doing literally anything else, so if you're doing image classification, if you're doing object detection, if you're doing any regression problem, literally at all, if you're doing time series classification, you should use Keras. You should not use TensorFlow. That is my claim. We can fight about it later for sure. All right, so the last thing that I think is interesting in this specific piece of code is what happens here. So once we have done the predictions and we've gotten our predictions, and this is pre-trained, so we only have to run it on the predictions. We don't have to do the training piece of this because ImageNet, if you're not familiar, ImageNet is, I believe, 3 million images and 1,000 categories that were pre-trained by some researcher who was super amazing and hand-labeled all 3 million images into each bucket. So that's kind of nuts. They did a lot of the work for us. It is expensive and hard to do object detection. There are other algorithms that have made the performance better, but as far as I know, I think this is the only object detection at scale sort of thing that I know of. There may be other ones. Happy to hear about those if they exist. So I like this one a lot. And then what you can do once you have your predictions, right? So right now, these are just like numbers in an array. You do decode predictions, and then it gives you the semantic categories back. Hooray, which is what we care about. So you'll notice there's some other things going on here. I didn't just write a object detection thing. I also have Elasticsearch here. So now I've got like image search locally or on the internet, not on this website, because the search doesn't work here for a lot of reasons. One, it'd be super racy pictures, and I really don't want to expose anyone to that who goes to my website. Two, I've given this talk to teenage girls, so I definitely don't want them to see it. And then like 3, I don't want the traffickers to know that I'm looking at them specifically. I feel like it's a visceral reaction if they find my stuff, if they like see like, you know, one of their victims in one of these pictures. So the data's stale, but like there are closed source versions of this that are behind passwords that do have the search, obviously. All right, so going back into the code. So for those of you not familiar with the Elasticsearch API, in Python, it's super easy to use. You just have to pull in the Elasticsearch object, and then you can do a little bit of magic. I'll get into this a little bit more later, but more or less, let me just drop down. Wait, where is it? Okay, so I'm saving it to the database. Okay, I think this actually might be further down in the text. Oh, I'm not actually, okay, so some of this is commented out, whatever. Oh no, it's over here. Yes, it's over here, sorry. This code's a little hacky. The open source version is not as up to date as the closed source version. That's why I'm sort of like, oh, what did I do here? This is something I've written, it's been a while since I've worked on the open source version. So anyway, so once you have the images, which I'm saving to a database for obvious reasons, I can then dump things into Elasticsearch just by doing ESIndex, giving it the index name, the doc type, and then the data. Here, the data is not the image, it's the labels, and then the file name is also going into here. So it's the label and then the file name. The file name is referenced by the web version of this, and so you get the image and you get the labels associated with the image. So this is like a really nice operationalized little tool, right? Like you can use this if you want to see what pictures of your cats from your vacations are like doing things, but it also can be used for this real world use case. Now this has some marginal benefit for people in the anti-trafficking space, but it's just like a fun thing. So I'm spending some time on it because this is a data science conference and we should talk about data sciencey things. All right. So that's Investigator. It helps people to some degree. I personally am a fan of it, but like there's still some things that need to be worked out before it can actually be operationalized or useful for anyone. And so there's a lot of work for building a system like this. All right, so the last thing I'm going to show you, and this one actually kind of frustrates me because this is the thing that most of the people that I work with really like and want to use every day. So I'm actually going to run this code locally. I guess whatever God you believe in, help me. Sorry. Okay, so most people laugh when they see this, so I'm just preparing you for how ridiculous it is. So this is the thing. This is the tool that I made that helps most of the people that I work with at any given time. Looks super dumb, right? That's because it is super dumb. I spent like 3 hours on this. So I'll just give a quick demo of what this does if I can find some data. I downloaded the talk somewhere. I think it's in AI-Conf. You'll have to excuse me. Okay, so here's the PDF version of my slides. I'm going to upload this. Great, it's uploaded. And now I'm just going to go back to the title slide, and I'm going to copy paste. And then we're going to search for that. Oh, cool, we found it. So this is like really bad user experience, right? This is like the most ugly, terrible thing that I've ever made in my life, and I'm embarrassed that this is the thing that people like want to use, but it's fine. It's fine. Everything is fine. I get really angry about this. Anyway, so what this does is it allows, all right, so I have to give you some context now for the DA's office. I just want to do, okay, so I have 15 minutes left approximately. All right, there's enough time for me to go into the full background. So here's why this is so much more useful than anything else I built. And before I get into it, I'm going to hammer at the beginning of this explanation and I'm going to hammer at the end that the reason why I'm showing you this thing is because it's not always the super sophisticated machine learning algorithm that's crazy that's going to save the world. Sometimes it's the really dumb thing that you built in 3 hours that for some reason social justice people find really easy. You got to understand where people are and meet them where they are. Most of these folks do not have search, okay? So that's the first thing I want to claim, and that's the reason why this is useful. Does everyone remember, maybe in the 1980s, if you were alive, this thing called, oh, now I have to remember the name, and I'm like blanking on it, of course. It wasn't the internet. It was like, you could, what? No. It's not that. It's mainframes. So, yeah, so most social justice, you're like, oh my God, it's that bad. So most social justice like organizations around the world use mainframes to this day. They do not have file search because they're on a mainframe, and they do not have really anything because they're on a mainframe. Now I don't mean that they're using like COBOL and Fortran. I mean that they're using Windows, but like really, really old Windows. Now we're in Microsoft, so I want to be clear. Microsoft of today is awesome. Actually, the fact that they've pushed into open source and that they built their own Linux, these are all super amazing things. And the company of today is way better than the company of 10 years ago, but so is everyone. So like, we shouldn't fault them too much. But yeah, so they're running these really old, like Microsoft hacked together mainframes that the IT people understand. And so everything just lives in this giant mainframe. And there's like 10 million, 100 million files. And these are all case files and personally identifiable pieces of information. And they're all running on Windows XP. So the world is a magical place sometimes. So what this tool does is it gives them efficient and effective file search. Now we're going to look at the source code. It's laughably small, so we can do it in 13 minutes. But the point here, and I'm going to drag you through the mud, hitting you over the head with a hammer, or whatever metaphor I need, so that you understand, it is the easy thing that saves lives. It is not the super sophisticated machine learning thing. That's why I gave you the scikit-learn and the VGG16. Those are sexy applications that we all care about, but like these folks don't always. Anyway. Now that I've beaten you over the head with a thing, I can walk you through the source code and we can all be sad together. You're with me now. We're on the journey. You're not allowed to back out. Okay, so there's a few things that happen. The first thing is I parse the files. So I'm using Elasticsearch again. This code is a little bit more maintained, so I know my way around it a little bit better. It's also a little cleaner because I only worked on it for 3 hours. So this is a docx. Python's super awesome. It comes with a document library. You can parse documents. Super cool that you can parse docx's. What this does is it looks for any docx's when they get uploaded. It reads like the thing that happens in the view. Don't worry about that now. Excuse me. But this assumes that I'm passing in a docx file. And then what it does is it just adds it to the index. Remember when we looked at Elasticsearch, we're just adding it to the index. So we add it to the index, we add the data, so that's the text in this case, and then the title of the document, and then we go back up a directory. Now, yeah, I'm using a file system on the internet, which is bad practice, and I know I should be using S3 and all this other stuff, but I built it in 3 hours, so cut me some slack. All right, so the simplest one to implement was parse text. This took me 5 minutes, and then I started thinking, well, maybe I could do this one, and that's sort of what led to that. And then here comes the backflip. All right. So remember how I said before that machine learning isn't really useful for these people? I want to make a caveat. Machine learning can be so useful to these people when they don't need to understand that it's being used. They don't understand the nuances of machine learning. They understand, cool, you made my life 10 times easier. And so you can always do those sorts of things. Now, Granted, again, this is like not the right way to do this. I could have done a lot more training for this. I'm using the out-of-the-box solution from Octopus, which is now called OcroPy for some reason. So OcroPy is an OCR solution. It's super great. I really recommend checking it out. One of the reasons why it's so amazing is because it comes with a pre-trained recurrent neural network, but you can train your own. So you can always make your OCR domain-specific, PDF style specific. We have solved the parsing of PDFs problem in the machine learning space, I think. And this is an example of how that does that. Now, this is like a hacky thing. I'm using some command line stuff, which I know is terrible. I apologize to the gods of clean code. But this, got the job done in 3 hours because my life is too busy. At some point in the future, I will probably return to this and A, train a better recurrent neural network on this, and B, actually learn the internal interfaces so that I don't have to deal with these command line arguments. Basically what this is doing is it parses the file, it puts the pictures into this weird temp folder with question marks for some reason. It runs the recurrent neural network against it. Because it's text, it goes character by character across and recognizes each one. Think of this like MNIST except operationalized. So you could probably get a lot more mileage out of CapsleNet or a ResNet or some other thing. I don't remember if ResNets are used for character things. I feel like it was trained on MNIST at some point, but that might not be true. So maybe that one is wrong. I know CapsleNet was trained on MNIST because I just read that paper a couple weeks ago. So yeah, I can say with certainty that CapsleNet would get improved performance over this vanilla recurrent neural network, and you would just have to run this against this. Anyway, not important. So then you have this, this last step, which basically turns it into an HTML document. HTML documents are things that the internet, as well as Python, knows how to parse super well. We just take the HTML document, we do a from string, we ignore some ASCII things, and then we get the text. And then we're able to just turn it into here. So this is dealing with picture PDFs. These are PDFs that were scanned in, which is true of most legal offices that can't afford an army of paralegals, which is most social justice offices. So you're thinking ACLU, you're thinking most anti-trafficking NGOs, you're thinking, I don't know, whatever social justice startup you want to think of. Maybe Doctors Without Borders as well. Not to call them out, I don't know if they all do this. I'm assuming the ACLU does, and I know some anti-trafficking NGOs do. All right, so, and then, if we're lucky enough, if we are in the universe where this is a PDF that has been OCR'd already, or is just text readable because it was translated directly from the Word document that someone wrote, and then they emailed it to someone else, in that luckiest of lucky worlds, we can just do PDF to text and then to pass in the dash layout command. I have not figured out a better way to do this. This will probably live this way forever. I apologize. There are tools like in Python called parse and a bunch of other stuff, but I haven't found them to be super compelling. PDF to text is super compelling to me. You pass in the file name, and then it takes it from a PDF and turns it directly into a TXT file, and then I call the TXT parser. So that gives us pretty much what we need. And that's why this thing is a beast. It'll work on any file type that most of these people have. Now, why is this super useful? Okay, most people don't last at NGOs for more than about 2 years. The pay is terrible, the hours are awful, and the work is heartbreaking. So you go into this NGO, maybe you work on a legal case for 2 years, then you leave to go back to the big fancy law firm that you came from. All your domain knowledge goes out the window when you leave, and so they're left in a lurch. So if they want to find the files that you worked on and it's not in their head, before this tool, they had no way of recovering those specific things. So they really need this to be able to say, okay, we found this guy with a phone number who's related to that other case that we worked on 4 years ago. Does anyone remember any of the specific pieces of information? And this is really a lawyer's talk. They don't take notes in a detailed way because anything you write down, if you remember it, you have to turn over. I can't remember what the name of the legal thing is, but you'll have to turn it over. What? Discovery, yeah. So lawyers are trained to not take notes, whether they mean to or not. I'm not saying there's something adversarial here, although there is something adversarial here. They don't take notes they take notes when they have to, but they don't take notes a lot of the time. Sorry, that was really confusing and in my head. So they don't take notes a lot of the time. And so these PDFs are really the only way that they'll be able to recover a piece of information. So this is both helpful and can be hurtful to a case, but on the whole, it's helpful because then they can make the internal connections between this trafficker and this trafficker over here, do the social network analysis, and then if this trafficker, there's a legitimate case against them, and this trafficker we don't know, but maybe there is, you can join the two of these people together based on salient information that is personally identifiable, like a phone number, which is basically like a unique identifier, or their social security number, or in some cases, to a lesser extent, their name or their address, then you can prosecute both of these people. Now, I won't get into why this is like super useful to a large degree. There's other talks that I've given that you can check out. The long story short is that trafficking victims basically don't want to deal with the legal proceedings. They want to get out of being trafficked, obviously, and then they want to go away. That makes sense. Legal cases are really hard. There's a lot more nuance there. I'm not doing it justice. Please look at other talks online to understand why in more detail. But yeah. So that's why this is the most amazing thing I've ever built. And if you want to work in social justice space, I hope you do. I hope that this has incentivized you that you can at least try to, or at least, you know, maybe do data kind, help out on the weekends. All of these things are options. You don't have to make it your day job. Now, shameless plug at the end, I get to work on social justice stuff every day because I work at this place. We do social justice stuff. That's like part of my job. Anyway, so that's like shameless plug thing done. Here are a whole bunch of organizations that are doing things. I always reference this one first. Why does my internet not work? What? This worked like yesterday. Okay, maybe not. Is it this one? Come on, internet. Oh, maybe it's down. Whatever, I guess their internet thing is down. That one is like they write you a check for 15 grand if you want to do it. I guess it's just like they stop paying for it. So maybe that's not happening anymore. Anyway, whoops, should have checked. In any event, there are a lot of organizations that do this. I worked with Bayes Impact a little bit when I was at the White House. They're super great. They do data science for social justice. They're a nonprofit, but they help people. Beta NYC is here in New York City, the largest social justice meetup, I think, in the world, definitely in New York, and for sure in America. They're super amazing. Noel Hidalgo is like their leader, and he does a lot of amazing work, and they do data science for social justice. They were the first in the space. And they helped me a lot early in getting to the right people when I was starting out. So, you know, they are an amazing group. And if you want to do this work, they're super great. A bunch of these other things. Code for America is another one that I'm going to call out specifically. They do a lot of great work. A lot of people that ended up at the White House when I was there did Code for America first. So there's a whole career path for getting involved if you really want to make this your career. And then there's a whole bunch of other organizations that I've been tangentially involved in. But all of these are amazing. And you should definitely check out every single one of them. Okay. So I think we're at time, right? When do I go until? 12:10. Oh, I've got like 10 minutes. Cool. So I'll take the last 10 minutes for questions. All right. Anybody? Oh, one over there.
Awesome job.
Thanks.
Question about what you showed the map before, like the implications of your work.
Yeah.
Is what you, whatever algorithm you come up with or whatever work you do, whatever code that's based on, is that enough grounds for like an arrest warrant or like search warrants or like stuff like that? What's the legality on that?
Yeah. So just to repeat the question, what's the legality on this tool in particular, right? Yeah. So this is not enough to make an arrest. This is enough to start an investigation. That means that they can go to a judge and say, hey, this person is shady. Give me a warrant. Great. Then they can go, not a warrant for arrest, a warrant for a search warrant, yeah, to like start investigations and stuff. That's all that means. Before that, you can't even look at a person like, we do general, human trafficker, people involved in anti-trafficking work do general discovery things on a regular basis. And so they're constantly looking for, traffickers to prosecute because witnesses usually can't come forward because they're enslaved, right? So like it's kind of hard. So when they're doing this discovery for people, they get enough evidence so they can get to the next level. This definitely helps with that. Not enough to make a huge impact. This tool is maybe being used by 2 to 3 organizations, so like not that much. But like, yeah. So, but this allows them to open the door. Before that, they couldn't even open the door to the investigation. There's been a lot of people that have done the discovery work. Actually, like, I think there's some people who do num-focused things that also help with this, and like other things generally. The Python community definitely has been involved, which has been wonderful to see. Yes, next. Okay, 1, 2.
Do you know if you use similar techniques to what Thorn is using?
Yeah, I know I do. I have friends at Thorn, yeah. So I'm actually just about to start a doctorate, probably. I don't know, whatever. I'm like pre-doctorate land. I'm helping a professor with a project right now, and it's probably going to turn into a PhD. And his last PhD candidate went to Thorn, and I'm taking over her research. So I know for sure that I'm doing things that are similar to Thorn. Not this stuff. This stuff is not related. So that stuff's super fascinating. I'll say the high level. It involves cryptocurrencies and payment methods. And then I'm going to wave my hands, and like you can go read the paper, because that's like a whole big thing. But yeah, there was a Thorn hackathon, just to call it out. There was a Thorn hackathon like a couple of weeks ago in New York City. It was super great. I went. Ashton Kutcher was there, which was really weird, because he like funds the organization. And I was like, oh, you're 10 feet. Okay, cool, whatever, weird. That was interesting. But yeah, we got to work on a bunch of stuff. There were a lot of great projects, and a lot of people did a lot of great stuff. There's definitely people in the space, and a lot of folks, a lot of familiar faces that I've seen from other social justice things. Okay, you're next. Oh, you're good. Oh, okay, cool. Answered your question. All right, 1, 2. So you and then him. Oh, sorry, can you say louder? Oh, yeah, sorry. I didn't like go into that at all. It's really gross pictures of men and women being naked in various contexts. So there's this website called Backpage. I will not go into detail about them or what they do, but they have a dating section, and most of those are just prostitution ads. Yes, that all comes from websites like Backpage. There's a ton of these things on the internet. So I don't give this context because this is not an anti-trafficking talk. This is how you can do social justice work in the real world. But the internet has fundamentally changed, and I'll just give the spiel quickly. The internet has fundamentally changed the way in which the value proposition around sex trafficking has evolved. The internet has made it cheap and easy to connect buyers and sellers of all stripes and sort of flavors. And unfortunately, this means it's easier to buy and sell people. And so with the rise of technology and the internet, we have created sort of a crisis. We've made, sort of the sex trade, or the human slavery trade 2.0 on top of everything else. Silk Road has, provided a lot of ground for this. Websites where you can buy and sell people. All of these things, creating a secondhand market. Honestly, cryptocurrency has been a big part of this because it's not tracked or regulated by any nation. Part of the reason why we have laws and consequences is because we can track these things and we can control for certain things. We can audit stuff. We can't do that with this new technology. And I'm not saying technology or innovation is bad necessarily, but there are consequences often unintended that we need to take care of. And this is an example of how technology has led to sort of the bad. So my claim is that we can do better, and we should, and that's part of the reason why I do this work. Okay, you and then you, right? You had a question? Oh, sorry, I thought I saw you raise your hand. Okay, so you're next.
Yeah, would you say that there's enough talent for young professionals in terms of social justice? Wow.
Absolutely, we have an internship program at my job. So I didn't want to give a plug about where I work because that feels really wrong, but I'll explain what we do. So we work with law enforcement agencies, and we help them try to better understand how to effectively do community policing. So our value proposition is that we want people who are getting policed by the cops to have a say in how they are policed, and for the cops to better understand when they're upset about a thing so that the cops can do better. This directly relates to the anti-trafficking work I do because the algorithms are similar, and then I can sort of take what I do here and then give it to the anti-trafficking people to some degree. We have an open source footprint, all this stuff. We have an internship program. So we're an example. I'll just say that. There are other examples. Bayes Impact is another example. I don't know if they have internships. I'm not as familiar with their hiring process, the only reason why I said us first. But I know for sure that they definitely do stuff. I don't know if the ACLU does this sort of work with technologists, but I imagine you could reach out to them and they would be super responsive. Every NGO that I have cold emailed has gotten back to me within 3 days. There is plenty of space for all of you to play. If everyone in this room decided they were going to not quit their jobs, but to, do 5 hours a week for one of these social justice things, I bet you we would move the dial on every single social issue out there that matters. Anyone else? Okay, going once, going twice. All right, thanks everyone. I really appreciate your time.